Everyone, in today's video we're going to be going over three main things. The first thing we're going to be doing is we're going to be taking a look here at the Antoine equation, and we're going to be talking about how this relates to the phase diagram of a pure substance. And then after that we're going to be taking a look at some experimental data, and we're going to be using that to calculate an A, B, and C values for a particular substance. And then we're going to be using that and we're going to plug it into this here equation to come up with a line of best fit for that specific substance through a nonlinear regression firstly, and then after that we're going to do it using a linear regression. Alright, so firstly let's hop into the Antoine equation. As you can see here, it says that the log base 10 of pressure is equal to A minus B over T plus C. And these A, B, and C values right here are just coefficients. They're different for every substance out here. It's not one particular value. You would find these through experimentation, and yeah, that's what we're going to be doing later on. So basically what this is trying to tell you is that if you have a pure substance, and it's important to note that you do need a pure substance for this, it's not going to do anything for a mixture. You do need to have one particular substance in isolation. And basically what this is saying is that if you know the pressure of the substance, then you can know its temperature too, or the other way around. If you know the temperature, you can calculate the pressure from it. Alright. So when using this equation, you need a substance that is somewhere along this line on the equilibrium between the gas phase and the liquid phase over here. And as you can see here, this phase diagram uses the same two variables as this equation. Over here you can see it has pressure and temperature right here. And over here the phase diagram has pressure and temperature. So let's say you had water and you wanted to figure out what the pressure of water is at a certain temperature. And let's say the temperature was right over here. I'm not sure, we'll call this like 200 degrees. And we'll go on up to right here, and you would go over to the left and be able to calculate its pressure. So it's pretty much finding this line right here so that you can calculate the pressure or the temperature depending on which one is your known and which one is your unknown. And yeah, that is basically how the Antoine equation relates to the phase diagram. Oh yeah, and another quick thing I forgot to mention in the video is the temperature when using the Antoine equation does have to be in Celsius. I'm not sure why this graphic here says Kelvin. I picked this one because it looked nice and it's got all this pretty stuff going on, but yeah. When you're using the Antoine equation, do make sure that you're using temperature in Celsius and not Kelvin. Alright, hello everyone. In the second part of today's video, we're going to be using the Antoine equation to create a line of best fit for a data set that was recorded earlier. The data set took the pressure and temperature of a water sample, and we're going to be using Python to create a nonlinear regression first and then a linear regression later. Alright, so the first thing we're going to want to do here is we're going to want to get to our data. Over here you can see it has recorded the temperature in Celsius and the various pressures in pascals that correspond with those temperatures. So the first thing we're going to want to do is we're going to want to get the raw file. We're going to copy this link over here. Alright, and then we're going to use the wget function, copy that link on in there so that we can get that data set loaded up into a matrix. Alright, and then we're going to import our numpy as np so that we can use all the numpy functions. Alright. And then we're going to be using the load text function over here to get the file on into the matrix. Alright, so the file name you can see right here is saving to waterpressure.csv. So we're going to copy that on in there. Alrighty. Don't want to put that inside the comma. Let's go right there. Then we're going to set the delimiter so it knows how to separate the values. And we're going to make that into a comma. As you can see over here, it is using the comma to separate all the values, so that's what we need to put in there for it. Alright, make sure that is working. Alrighty. So here you can see we have our array right here, so we're going to want to make a name for our array so that we can use that later. Alright, next thing we're going to do is we're going to want to separate the columns. We're going to want to make this, our temperatures, the x values, and the pressures are y values. So we're going to want to create an x column for these and a y column for these. Alright, so we're going to go x equals data, and we're going to want to go colon 0. Alright, so what this is going to do is it's going to separate the x column into all of the first row right here. It's going to be all of our temperature values. Alright, and then we're going to make sure that's working. 293, 303. Yep, that's working right there. Alright, and then we are going to go y equals data, same thing, except we're going to want to go to the second column. The Python index starts at 0, so the 0 is going to be the first column and the 1 is going to be the second column. We're going to go ahead and test out the y. As you can see here, that's working as well. Alright, and then we're going to want to import our plotly so that we can make some graphs for this. Alright, so the next thing we're going to want to do is we're going to get rolling and importing our make subplots function so that we can start creating some scatter plots for this data and get to visualizing it. So we're going to go from plotly.subplots, and then we're going to import make subplots, and then we're going to go plot equals make subplots, so we don't have to keep writing out make subplots every time we want to add a new plot. There we go. Alright, we don't need this here anymore. We know that our matrices are working, so we're going to go plot.add scatter, and then we're going to go, not parentheses, we're going to go x equals x, we're going to go y equals y, and then we're going to go, our mode here is equal to markers. Alright, let's make sure this is rolling. There we go, and there you can see we have our scatter plot right there. Looking good. Alright, and the next thing we're going to want to do is you take a look here at the Antoine equation, not Antonio Brown. You can see that it is taking the log base 10 of the pressure. Alright, it's not just taking the normal pressure values. So the next thing we're going to want to do is we're going to want to add some log values to all of our pressure columns, which would be the y. So we're going to want to go. Alright, so the next thing we're going to want to do is we're going to want to create a log with a base of 10 for all of our y values. So we're going to go np.log10. We're going to do that for all of those values. Alright, and we're going to switch up our name for this so that we know we've put the log in there. We're going to redo that for the graph as well. We're going to make our y values now log y. So you're going to go y equals log y. Going to go shift enter, shift enter. There we go. Why is it making the two traces there? Alright, so I figured out our issue there on why I was creating two graphs. It was because we had the plot equals make subplots up here. So I just moved that on down here. And now we got it working again. So as you can see, we have our one nice and pretty plot here. So now that we've created our scatter plot for our data set, the next thing we're going to want to do is we're going to want to create our Antoine equation and fit it onto this graph. And to do that, using nonlinear regression, the first thing we're going to have to do is we're going to have to create a sum squared error. Alright, so we're going to go define SSE, and then we're going to go put the variable for that as v, and then we're going to go over here and we're going to make V is equal to A, not period, A, B, and C. Alright, not class. Alright, there you go. And so now we're going to have to set the Antoine equation equal to 0. And to do that, all we're going to have to do here is subtract the log base 10 onto the other side. So we get 0 is equal to A minus B over C plus T minus the log base 10. You could also go the other way. You could add the B over C plus T and subtract the A, but we're going to do it the other way around here. Alright. So we are going to go, here, let me do this. A minus, here we go, B over C plus T. And actually, our T's are actually going to be our X's over here, so we're going to go plus X. And then we're going to go put some parentheses around all this just to be safe. And then we're going to go minus log y for our y values over there. Alrighty. And then we're going to want to minimize our sum squared value. Alright, first thing we're going to want to do is we're going to want to square all of this because it is a sum squared. There we go. And then we're going to want to minimize SSE. And then we'll make our guesses. We'll go, I think we do brackets for that. We'll go 1, 1, 1. We'll run that. Invalid syntax. Alright, so I believe we have our syntax issue sorted out now. So we'll go ahead and get some parentheses going around all of this. Get a comma there. Alrighty. There we go. And another thing I forgot to mention is we are going to need to be summing our squared values. So we're going to get an np.sum going in there. Get that going all around. And we are going to need to return this so that the minimize knows what it's trying to minimize. So basically what this is trying to do is the minimize is taking the value here from the function and it's trying to get as close to 0 as possible. That's how you fit with the nonlinear regression. So we'll get that running there. Alright, and here we have our values for that. Alright, so the next thing we're going to want to do is we're going to use these A, B, and C values and we're going to put that into the Antoine equation and we're going to create a line plot for our Antoine equation. Alright, so what we're going to want to do here is we're going to want to go to plot equals, here, let's move, we can make some separate graphs I suppose. We'll go to plot dot add scatter and then we'll go x equals x, and then for the y we will go pull up the Antoine equation here. Alright, so we got the Antoine equation pulled up right here, so we are going to go y is equal to a minus b over c plus x. Because remember our x values up here are our temperatures, so we're going to substitute that in for the t. Alrighty. Around that. Actually, we got to put in our lines. Mode equals lines. There we go. Alright, figure offset. Alright, so we gotta go to add scatter. There we go. Aim A is not defined. Alright, so okay, so we gotta go to dot x, because this is x telling us that right there. Alright, and then we go to let me see here. bring that down. Alright, we go to A, B, C equals array. Alright, so we actually don't want to do this A, B, C equals array down here, so I'm going to delete that. We actually want to go to up here and put in our A, B, C, and V values, because we already have this down here, so it'll automatically know to make A the 10, B the 1700, and C the 36 right there. So we go to Shift Enter right there. Alright. Then we're going to bring in our other plot stuff over here so we can get it all in the same graph. We're going to copy that. And we're going to bring it right here, paste that in there, get this all in one graph. Alrighty, here we go. And as you can see, there we have it. It is on the linear regression there. It is fitted to the lines, but as you can see, it is making a straight line in between each of the points. It's not making a nice smooth curve. So we are going to have to import more x values in there so we can make it a nice smooth curve and not make it so it's using all the same x values as our data over here. We want it to have its own x values. So we're going to have to create some new x values. So for that we are going to do np dot alright, we're going to do np.linspace over here. Then we're going to choose our starting value. We're going to want it to be to the left of the leftmost value of our scatter plot, alright? So the leftmost value on our scatter plot is 293, so we'll make this one 290. Then make our upper limit higher than this one, so the rightmost one is 647, so we'll make this one 650, and then we'll add 150 points. Alright, and then we're going to have to come up with a name for this so that we can add it into our plots for the x's over here and over here. Alright, so we'll just go with xplot equals that. Alright, so then we come down here and add it for our x and y values so it knows to change that. There we go. Alright, extra parentheses, don't need that. We'll run that, and then we'll run this. Alright, and as you can see here, it's nice and curved. It's got all these equal points in between. It's no longer following just the x values of our scatter plot. It has its own x values now, which is creating this nice nonlinear regression curve right here. And yeah, that is how you use the Antoine equation to create a nonlinear regression. Alright, so the next thing we're going to be doing in today's video is we are going to be transforming the Antoine equation in order to enable us to use a linear regression on Python to fit to the data that we have. Alright, so what we're going to want to do here is we're first going to want to take a look at the Antoine equation. I have it written out right here, as you can see. Log base time of the pressure is equal to the A minus B over C plus T, right? Same equation we were using in the last part of the video. And what we're going to want to do here is we are going to want to use some matrix multiplication to figure out what A, B, and C are. And to do that, the first thing we're going to want to do is we're going to want to transform this so that all of the items that contain A, B, and C are going to be on one side of the equation, and then all items that exclusively contain the things that we have data for, like T and P, are on the other side. Alright? So the first step in this is we're going to multiply everything by C plus T. Alright, so we're going to get C plus T times the log 10 of pressure is equal to C plus T times A minus B. Alright, and the next thing we're going to want to do is we're going to multiply these out right here. So we're going to get C log 10 of pressure plus T log 10 of pressure is equal to AC plus AT minus B. Alright? And now what we're going to do is we're going to move all items that contain A, B, or C over here onto this side, and then we're going to keep anything that has exclusively T's and P's in it on the left side over here, alright? So this item right here, it has a T and a P, no A, B's, or C's, so it's going to stay on this side of the equation, alright? And this one, this has a C in it, so it's going to get moved over, alright? Everything over here has an A, B, or C, so it's going to stay over here, alright? So we're going to have T log 10 of the pressure is equal to A T, right, minus C log 10 of the pressure, right, is equal to our mean plus AC minus B. Alright, and from here we can start writing our matrices. Alright, so we're going to start over here on this side. So the first matrix we're going to have right here, we are going to take the A out of this one, and we're going to get T1, T2, all the way down to Tn. Alright, and then for this one, we're going to have negative log 10 of the first pressure, negative log 10 of the second pressure, all the way down to negative log 10 of the nth pressure. Alright, and then this AC minus B over here, you're going to make that into one coefficient. We're going to call that D. Alright, and there's nothing to take out of the D, so we're just going to make this a column of ones right here. Alright, and then that one is going to be multiplied by another matrix over here with A, C, and D. Alright, those are going to be multiplied together to equal T of the first pressure times log 10 of the first pressure. Then that's going to be T2 times log base 10 of the second pressure. And then that'll go all the way down to Tn times log 10 of the nth pressure right there. Getting a little bit messy here. Alright, hopefully you guys can see that. Alright, and then from there we're going to do our matrix multiplication. Alright, so you have this over here, we'll call this matrix M, is going to get multiplied by the vector here, so that's going to be U, and then that is going to be equal to B, alright? We're calling this matrix B, alright? So this is going to be, we're going to do the M transpose times M times U is equal to the M transpose times B, alright? And what this is going to do is this is going to give us a 3 by 3 over here, and then this vector over here is a 3 by 1, and that is going to give us our 3 by 1 over here, which is going to give us our A, our C, and our D values, and using these three values we can calculate our B, which is going to give us our Antoine equation, which we can use to fit to our scatter plot, which means we are fitting this by a linear regression. Alright, just realized you might not have been able to see the bottom of the whiteboard there at the end of the video there. Getting a little bit down crooked, but there she is in all her glory. Alright, so we are back here in Python and we are getting ready to do our linear regression for the scatter plot using the Antoine equation, and we already figured out all the matrix math. All that's left to do now is do the coding for it. Alright, so we named our matrix M in our earlier video. So we're going to do M is equal to np dot c underscore, and then we have for our one column we had our x values right here, and then we had our negative log y values Let's see, what did we call that column up here? Yep, log y, alright. And then we are going to do an np dot ones like x. Alright, because we just want a column of ones here and it'll have the same number as the x. Alright, we'll finish that out. Alright, invalid syntax. Okay, don't need that there. Alright, let's print m. Alright, and here you can see we have our matrix here. That's looking good. Alright. Then we need to do our matrix math. So we had the transpose of Q, right? And then we had that, or I mean M, and then we had that. And then for our matrix math, we had the transpose of T multiplied by the matrix itself, and then we're solving for the vector, so we don't have to put that in the equation. So we have our left side of the equation here, and then on the right side we had the transpose multiplied by our temperature times the log base 10 of the pressure, which for us was something different. I believe that was the x times the log y for us in this specific example. Alright, so we got all that set up, and then we need the np.linalg.solve to solve this up for us. See here, alright. So we got our A2, our C2, and our D2 values right here. So we're going to go ahead and go A2, C2, and D2 right here. Set that equal, alright. And then I believe the B2 is equal to the A2 times the C2 minus the D2. Alright, there we go. And then we can print our A2s, our B2s, and our C2s to make sure that they are aligned with the ones we got earlier over here. Alright, so we're going to go ahead and print the A and the A2. Make sure those are close. Yep, those are looking good. Alright, we'll do the B's next. Alright, the B's are looking good. Alright, and the C's are looking good. Alright, so we are all set to go ahead and plug in our linear regression values and make our linear regression here to go along with the nonlinear regression in the scatter plot. Alright, so we're going to go ahead and copy and paste everything down here again. Alright, here we go. And we're going to add another plot. Alright. X will be the same thing, and then the Y will be the same thing except with the A2s and the B2s and the C2s instead of the regular normal A's, B's, and C's that we used in the last one. Alright, here we go. Plus the X plot. There we go. Alright, and this will be in the lines again. Alright, and we should be all set. Alright, there you have it. There is our linear regression. As you can see, it's pretty much the same thing as the nonlinear regression. They sit pretty much right on top of each other. And you can see they have a little bit of difference, but not too much. And yeah, it's as simple as that. And that is how you do a linear and nonlinear regression of the Antoine equation. And yeah, have a good one.